Alright, we're going to begin where we left off, and we were able to find the area using graphing the two functions and then finding the difference of those two functions, graphing the difference and using the integral function as we saw there. So the area that you see on the screen doesn't appear to have anything to do with the area that you were looking at between the two curves, but this is the same, or that's an equivalent area under that curve there. But that's the difference of the two functions. And this is the way that the calculator will find that area between two curves. All right, let's talk about now how we would go about the next step. Now if you recall, the next step was that we needed pi capital R squared minus little r squared, or pi capital R squared minus pi little r squared. And so rather than again type these things in all over again, I have a couple of options. And normally these types of problems are multi-step and you're going to use the same functions over and over. Rarely will they be as simple as the ones that I've put in here. So what you don't want to keep typing those functions in again and again, because you're only going to open the possibility that you'll make some data entry error. So instead I'm going to disable that particular function that we just worked with, and now what I want is pi, and my capital R is just y2. So vars y vars function y2 squared minus vars y vars function y1 squared, close paren, and now I have the function that I'm looking for there. So that is the volume function. Now again, we can go and graph this. Again, it's pi capital R squared minus little r squared, and we could have built that into the y3 expression there, but I leave it in case I need to go back to it the way it was. So I'm going to go and graph that, and you can see now we have another area. Now this area is really a two-dimensional representation of that three-dimensional volume. It doesn't look like the volume, but it is a volume expression here. And so we're going to find the area under that curve from 0 to 1, and that is, again, I'm going to store this time in B. And we said that our answer to the second problem was 5 pi over 14. So 5 pi divided by 14, and it came out to be exactly the same. So that's a way that we would go about using the calculator to find those volumes. And again, you go back and look at you can almost see the pi capital R squared minus little r squared in there, just by putting your functions in and creating the volume function, and then graphing and using the definite integral function to find the area under that curve. Again, you're working with a two-dimensional representation of a three-dimensional volume, so it doesn't look anything like the problem, but that area, the integral of that function, or the area under that function curve, gives you the three-dimensional volume. I hope that's clear. Okay, so we'll go on to another one. We'll do a couple of these to make sure that it all sinks in.